2016 Istanbul Transport Congress and Exhibition is taking place at Istanbul Congress Center on 1st and 3rd December 2016 on the behalf of Istanbul Metropolitan Municipality. TRANSİST is a platform that leading new product and technology of the transportation sector with the theme of 4T: traffic, timing, transform, and technology. TRANSIST 2016 Istanbul Transport Congress and Exhibition aims to ensure a sustainable exchange of information between local authorities and industry representatives regarding academic topics for the transfer of new technologies and strategies in the field of transportation. Smart Mobility Conference is a part of TRANSIST Istanbul Transport Congress and Exhibition. All sessions will be English with high level of executives and participants regarding to aim focusing on smart city mobility. In this content, there will be 4 sessions in 2 days according to same time with main sessions. All over the world, industrialization and knowledge-dominated service economies are reinforcing the role of urban centers. Many cities around the world have grown exponentially over the last few decades, but smaller cities in industrialized countries are also expanding, and this growth comes with an environmental and social cost for cities and people. Mobility in the early 21st century is shifting, and also in shrinking cities, smart technology and new behaviors are changing the way cities move. Cities may be at different stages of maturity around the world, but they all have to bring their development onto a sustainable path, and integrated mobility plans are key tools that can be used to address this challenge. Now, I will glad to invite Michigan University lecturer Professor Süleyman Uludağ for his speech.
Hello everyone, my name is Süleyman Uludağ. I am from the University of Michigan Flint, Department of Computer Science, and the title of the talk is Opportunities and Challenges for the Smart Cities of the Future. So, where should I point this? Okay, all right. Okay, so it's going to be a kind of a high-level talk. It's not going to be very detailed. There is not going to be any formulas, so don't get scared too much. This kind of the overview. I'll be talking about the urbanization first, the urban density movement. And I will be talking about the transportation ecosystem in conjunction with the smart cities, followed by the transportation landscape and the paradigm shift towards the smart cities. I'll be focusing somewhat on the connected and autonomous vehicles, CAVs, in terms of providing the solutions. However, these are not the ultimate solutions by themselves. They require end-to-end provisioning, which will be provided by means of the ITS or the intelligent transportation systems, by means of vehicle-to-vehicle, vehicle-to-infrastructure, and vehicle-to-grid subsystems. And finally, I'll have few words of conclusion for the talk. Again, this is some sort of a position paper, position talk. I'll provide some sort of an overview, followed by some discussions, and it's not going to be much technical content beyond that. So first of all, the urbanization trends. The urban density areas are increasing quite fast. The urban density or urbanization is the percentage of people living in urban areas as defined by the local institutions. So this is compiled by the United Nations, and the x-axis is the years starting from 1961 all the way to 2015, just last year, and the y-axis is the percentage of the urbanization. And if you take a look at the trend, it is somewhat linear, somewhat maybe quadratic, from 30% or 34% in 1960s all the way to 53.9% in 2015. So this is the worldwide average statistical information. And if you take a look at Turkey, for the same plot, for the same data source from the United Nations, first of all, this is the world, and the Turkey's urbanization trend is quite significant. So as you see, in 2015, it was 53.9 for the world, and it is for Turkey, 73.4%. And again, it's quite a significant change. It started off in 30% in 1960s and all the way to 73.4%, which means that this problem is compounded. This problem is much more prolific in Turkey than the rest of the world. And so the part of the trend, this quadratic trend that I showed you, causes a lot of problems in terms of congestion, in terms of pollution, in terms of noise, and many other dimensions as the population growth and the density increases. So this, however, comes with an innovation ecosystem that should hopefully provide some opportunities to take advantage or to utilize from these infrastructure. The cities are coping with these changes in regards to the aging infrastructure, which is becoming quite problematic. And in order to maintain the stability, the operational day-to-day systems and the maintenance and the financing of these services usually take a shorter view, shorter goal as a focus, which might come at the expense of longer-term solutions. That means that the resources, energy, time, and all the efforts might go into the short-term view, myopic or short-sighted view, that might come at the expense of longer-term or longer time frame solutions, which might return a better return on investment that might motivate or propel the urban innovation subsystem. So the problems are big and complex, as I'll be touching a few of those as I go through the rest of the talk. But together with the challenges, many, many opportunities may be becoming even bigger. And the solution is usually, within the past few years, proposed under the umbrella term of smart cities. So, first of all, just last year, you might not be able to see this, but it's right here in this slide. I can provide the slides for anyone. Just in February 2016, the President's Council of Advisors on Science and Technology in the US submitted a report to President Obama about the technology and the future of the cities. So they identified 6 key infrastructure and technologies that will facilitate development of the smart cities idea or the ideal. They include the transportation. Of course, this Congress is about the transportation. And energy. As part of the smart cities, there is a significant movement towards making more sustainable energy, more green energy in terms of the smart grid initiative. So energy is another component. Then comes the housing and the buildings, the greener buildings, better and more efficient housing and providing housing for these new growth for the cities. Then comes water. The water, I heard that Istanbul might be having some water issues. There is a significant water shortage and drought in California area for the past couple of years. They are rationing water, so it's going to be a significant problem, and the water for the future smart cities. Then comes the urban manufacturing and the urban farming. That might not be very relevant, especially urban manufacturing here. But the urban farming is another trend that is kind of gaining attention in order to provide different ways of localized farming for greener diet and better and healthy diet, including the aeroponics, the hydroponics, and and different farming techniques. So for the rest of the talk, I'll be talking mostly concentrating on transportation, and with some also efforts in the energy as well. Because of the time restriction, I will be able to only go at the high level, and I will be skipping the rest of the components here. So I'll give a few examples of the smart city initiatives from the US mostly. Los Angeles, for example, in order to take advantage of the innovation subsystem through the smart grid, they have provided the city data to a mobile app called Waze. The Waze is a crowdsourcing application that uses the information coming from individuals to be able to provide location of the police in order to avoid getting ticketed, or location of the potholes or any other infrastructural problems. So about more than 1.5 million residents in the Los Angeles area, providing instantaneous information back to the municipality, back to the city, so that the city will be able to address these problems much faster than its own resources. Another example is from Chicago. Chicago has got the array of things. They have deployed 500 sensors throughout the city in order to monitor the air quality, in order to monitor the pest infestation, and similar environmental issues for health and related services in the Chicagoland area. The final one is in New York. They have got some sort of a dated infrastructure with respect to US standards, of course. And they are kind of analyzing and creating index for the fire sensitivity of the buildings, so that they can know the hotspots and those areas that might be able to simply engulfed in a fire quickly. And that might be quite interesting, because I think the tragedy recently occurred in Adana region is quite tragic. And this might be able to help for these kind of situations, to be able to proactively map and maybe provide some prevention for these kind of problems. So here is another one, another statistics from TomTom. TomTom is a Dutch navigation and traffic company that provides information, and they have got a very interesting congestion index for yearly basis. And this is from 2015. They monitor 295 cities in 50 countries worldwide. And Istanbul is ranked at the third with the 50% congestion level. So what this 50% means is that on the average, commuters in Istanbul expect to spend 50% more time during commuting than the regular no congestion areas or a free flow state. So for example, this 50% means that on the average Istanbul resident will be spending about 15 minutes more for a regular half an hour trip in the city. And of course, the morning peak or the evening peak, the rush hour congestions are quite high. For your information, 2015, Istanbul was at the top of the list. Unfortunately or fortunately, depending upon where you view it, there was a significant improvement, 8% improvement from 58% to 50%, and the Mexico City simply climbed up to the top of the ranking. And so this is where the congestion level, we have a significant congestion problem in Istanbul in terms of the ranking. If you would like to see where Turkey's other cities are ranked in the TomTom's congestion index, we have 9 cities in Turkey ranked worldwide out of those 295 cities. So Ankara is right here with 32%, Izmir is 29%, all the way to Konya, which is about 18%. So it is not only Istanbul, there are many other cities in Turkey suffering from the same congestion problem. So if we take a look at the, all right. So transportation costs monetized, just to give you some sort of a framework or some sort of a viewpoint. So the cost of traffic collisions, I have looked up statistics. I did not do a overkill in terms of the literature search, but I just simply did a quick search. So in the US, the AAA is an American Automobile Association, a very well-established traffic emergency help company, Auto Club. And they have conducted a study in 2011, and they have put the traffic collision cost, the monetary cost of traffic collisions in the US at $300 billion a year. And I looked up the Turkish statistics, and I was only able to find one paper from 2012. The citation is here from the Journal of Yaşar University. And they put this traffic cost, collision cost, in Turkey about $4.3 billion in 2012, which I think is a little bit underrated, or the US is way overrated. I don't know, but it's a significant chunk of money. And the cost of congestion itself, in the US, it is reported to be $124 billion, with additional $50 or $80 billion for the health per year. And for Turkey, according to İSPAK, I don't know exactly what İSPAK stands for, one of the municipality organizations, I think, dated 2012, it is estimated to be $2.8 billion. I found another OECD report from 2008, likely dated, the data is dated to 2002. It put the congestion cost in Istanbul to $7.2 billion. So if you just only include the inflation from 2002, that $7.2 billion must have become quite a significant chunk of money, wiping out and eating the gross domestic product in Turkey. So, okay, a little bit slower. All right, so transportation landscape. This is a diagram from a very well-regarded market research company in the US, Navigant Research. They simply publish papers, very detailed, very deep papers about the future outlook expectations. And this is about the transportation outlook 2015 and 2050. So they have identified a couple important trends. The first one, okay, well, I'll learn how to use this one eventually, hopefully. All right, so this is the laser. So they've got the vehicle connectivity, vehicle-to-vehicle communications as one of the trends. They've got the electrification, the electrical vehicles. And then they've got the on-demand mobility, which is quite interesting. I'll have a few more words about this a little bit later. And then they've got the driver assistance, which is the autopilot. Just like the airplanes have got the autopilots when the pilot takes off and then stabilizes the airplane. He simply takes the hands off and then autopilot takes over. We've got the same autopilot feature in the cars that has started. So these are the trends. So in 2025, we'll have some inroads with respect to these four trends, but the major expectation is 2050, when all of these are going to be quite significant in terms of the provisioning services. How am I doing on time? I am doing okay. Time-wise. Okay. All right. So there is a paradigm shift. Ride sharing seems to be taking off. If you take a look at the statistics, when you purchase a car, at the very least, from the US perspective, I'm not sure about the statistics in Turkey or the rest of the US, 22 hours a day, about 90 to 95% of the time, your car sits idle somewhere, parked, not used. And so the transportation, that's the reason why for the newer generations especially, it has been observed that 18 to 34-year-olds in this age range, they call the millennials or the generation X and Y in the US for these guys. So these kids have significantly dropped the car ownership over the past couple of years. And so instead of owning, they simply go by without owning the vehicles, and then they simply use Uber, Lyft, Sidecar, Zimride, and Zipcar type applications to be able to take care of their mobility needs. And sooner or later, this will come here as well, if it doesn't already come here. And the car manufacturers have started taking advantage of this trend. For example, Ford, just last year, well, not last year, a couple months ago, introduced this credit link to be able to have a car owned by multiple people. And then GM Germany, which is Opel, has introduced the Car Unity app, again for the same purpose, those who would like to offer their cars for lease and those who would like to take their cars, who are looking for cars, they would like to try to do some sort of a matchmaking for this kind of stuff so that they are not left out of these new trends. Okay, so the main idea is the connected and autonomous vehicles, or CAVs. So shared ownership model seems to be developing. And through this, the mobility on demand as needed, rather than having a fixed car or fixed mode of transportation, the mobility on demand is being progressed. And I think Turkey has got a nice innovation and nice potential for this. And as you know, this dolmuş idea here is quite peculiar, that it has been developed here. I've looked up the history, but there is not much history about the dolmuş in terms of when they started and the like. But it is peculiar to Turkey. It is kind of innovative idea. So the question might be, can this dolmuş idea be taken to a new level to be able to provide some sort of a carpooling and to take advantage of the trends in the younger, newer generations for these new set of applications and the like? This is quite interesting, and I would like to spend more time on this. Maybe anybody would like to take this up. Please come and talk to me after the talk. So, as another part of the smart city infrastructure is the intelligent transportation system, or ITS. It's the advanced set of applications and services in terms of a variety of different modes of transportations to make the transportation safer, better, cleaner, and more effective for everybody involved. And it includes a lot of benefits. It is like everything but the kitchen sink type of list. Reduce fuel usage, congestion, travel times, reduce waste, improve living conditions, productivity, greater satisfaction, and like, I'm not going to spend too much time. Hopefully, if you would like to see the slides later, or if you would like to chat after the talk, we can do that. So the intelligent transportation system in a smart city will include vehicle-to-vehicle communication, vehicle-to-infrastructure communication, so that the traffic management and emergency management can be established, as well as parking help, smart parking, and as well as the power grid relationship with respect to parked cars. If you remember, 90 to 95% of the time, car is left idle in somewhere parked. So this can be used for that. And also a smart lighting management that might be able to let us make use of the energy in much more efficient ways. So the autonomous vehicle, if the autonomous vehicles are here, why are we bothering with the intelligent transportation system? Well, the answer is quite simple. Just like when you plot a function, the function might have a local minima and global minima. So the autonomous vehicles are kind of the local minima. Everybody goes after their own objective functions that might not be in the best interest of the whole society or the whole population. So the ITS will be able to provide a more broader perspective than the individual autonomous vehicles for the better, efficient, and effective use of the systems. So there are many issues, research issues for the autonomous vehicles from security, privacy, all the way to traffic management, parking, congestion, and routing. I'm just going to skip them. I just put them up here for reference. Many of these include many hot topics for future research. If you would like to chat about this after the talk, I would be happy to talk about them. So just another example, in LA for the smart parking, they have computed the total percentage of space occupied by parking. 14% of the Los Angeles greater area is for parking. And then when they did the same computation for the LA business district, downtown, the heart of downtown, 81% of the space is taken up by parking. And there is a study by MIT for the Singapore, the city-state of 4 million people. They claim that if they can take advantage of the CAVs, they will be able to eliminate the parking problem as well as the mobility solution for the whole city or city-state of Singapore. So if the parking problem is alleviated, then there will be a significant space left for the LA from 81%, and you can use this space for a variety of different purposes. There are many research issues. I'm gonna say a few words about the mass transit optimization. So in the city of Ann Arbor, where I am from, there is the M-City. University of Michigan has established a driverless testbed, 32 acres, about 13 hectares or so. And so what they do is they simply emulate the actual traffic conditions with driverless cars, pedestrians, and the motorized bicycles and the like, mechanized bicycles and the like, to be able to develop and deploy these connected and autonomous vehicle systems. So this is the aerial view of the area. And there is a research group in University of Michigan that is interested in the public transportation optimization. And in this, they have identified the CAVs and the data science, big data, data analytics are the two big major issues. In conjunction with the on-demand transit, they are developing a system to be deployed at the University of Michigan campus to make the public transit less costly and hopefully more efficient. They would like to deploy the same system for the Ann Arbor transit and Detroit area as well for the public transit. So this is what they do. They simply this is the Ann Arbor area, and they come up with the heat map, density heat map for the public transit. For example, the red areas are the most dense, and the bluish areas are the least dense areas. And then they simply come up with some optimization formulations to be able to do this on-demand mobility, some sort of a hub-and-spoke mechanism for the public transportation. And the vehicle-to-grid, again, is another interesting idea with respect to energy in conjunction with the transportation. With the proliferation of the electrical vehicles, there will be a significant amount of electrical vehicles in the system. So this is a plot from another Navigant research, this is Innovation Electricity research. Based on 5 different scenarios, they simply calculated the number of number of electrical vehicles, and as you see, the trend is huge. So if the EVs are going to be many in the future, then we might be able to do some sort of a extra side benefit in terms of charging and discharging cycle for the EVs, for the power grid, for the smarter grid. So in this diagram here, we've got the x-axis is the hour of the day, and the y-axis is the demand in megawatt, some sort of a power. And then this is a typical demand curve. So this demand curve is again from 1 a.m. all the way to midnight, is not uniform. And because of the nature of the electricity, the system, the peak, is going to dominate, or is going to dominate the actual needed capacity to be maintained, which is not good. I'm not going to go to the details. So this is the real demand. If we can somehow, some way, use electrical vehicles to be able to shift the electricity demand so that the effective demand becomes smoother. And this area is called the valley filling. If we can push the demand down, we are not changing, we are just shifting the demand, the power demand, then we might have a smoother curve for the power consumption, which is much more preferable by the power companies than the peaking demand otherwise. So there are a variety of research issues, but I think I've been taking too much time, so I'm just going to skip these. This is smart lighting by means of the motion sensor-based lighting system. When the pedestrians and the vehicles are not available, maybe we might be able to dim or shut off the lights. So there are a lot of variety of research issues in the vehicle-to-vehicle and vehicle-to-infrastructure systems. This is the US Department of Transportation IntelliDrive model for the vehicular networking. Again, I've talked about this one as well. I'm just going to skip that one. So traffic management is the is going to be collective and collaborative in the future. That's what our expectation is in terms of the CAVs. There are many research problems, as I have identified over here. However, there are some problems. So, does anybody know the Google autonomous vehicles that are being deployed in California area? Driverless cars. So, here is a Google driverless car pulled over by police November 13, 2015. And the reason was the car was driving too slow. He did not get a ticket, but it was pulled over, so kind of a problem. So here's another one, a couple months later. Well, Google was bragging that they did not get a ticket for this. And then a couple months later, a Google driverless car, autonomous car, kind of learned that they should not mess with the public transport, the public buses. So he was trying to cut into a public bus, assuming that the public bus is going to yield it to it. But actually, as you know, the bigger guy did not want to yield, and then so for the first time, a Google car got into an accident in California. And these are kind of the humorous aspects, and there is also you must have heard of the Tesla, the EV, electrical vehicle from US. So it's got the autopilot feature, and autopilot feature is thought to be more efficient and safer. However, back in May of this year, a couple months ago, in autopilot mode, the driver got killed. Simply, the autopilot could not see or detect, or the truck went under it, and then driver unfortunately got killed. So, yes, the CAVs provide a lot of potential, that they come with some problems as well. So my conclusion is there is a huge transformation taking place today in the world in terms of the transportation and in terms of the smart cities, and the prudent one should not miss this. There is a huge potential. There is a multi-trillion-dollar business that might be coming up, and then there might be new products and services as a result of this. So the innovation subsystem through the smart city might be facilitated by means of incentives, funding, or maybe grant opportunities for entrepreneurs, to researchers and the academics, or incubation centers for developing new ideas, because there is a huge potential here, not only for Turkey, but worldwide as well. There is a huge race going on in the world, or maybe test bed similar to MCT for the Istanbul's specifications rather than US specifications. So there's a multi-million-dollar industry, multi-million-dollar opportunity waiting. Why should we waste it? Why should we miss it? Thank you very much for your attention. If you've got any questions, I would be happy to answer any questions if I am allowed to answer questions.
Thank you, Mr. Uludağ, for his valuable ideas. Now I will glad to invite İSBAK Vice President Yusuf Tufan Erenay to present his prize.